Hello everyone. Now we will see the carbon dioxide laser. This includes the three parts. One is what is the basic principle of carbon dioxide, construction of carbon dioxide and its working. In many industries, the carbon dioxide laser is used for welding purpose, for drilling purpose, okay, for cutting purpose. I have given the link in the description of where all this strong carbon dioxide is used as different tools. Okay, let us look at what is the basic principle behind this carbon dioxide. Okay, so we know that we need energy to start with. Okay, or we can say this is the excitation source. This is the excitation source, or it is called as the pumping. Okay, we have to pump it. So this is the pumping on the active medium. Okay, so active medium, on the active medium we have to pump it so that this active medium is excited. So what may be the active medium? Active medium may be gas, okay, or it may be liquid, or it may be solid. So this is the active medium. That means what? It's a matter. It is the matter. That means when I give energy to this matter, it will be excited. Then what we have is, we will have the stimulated emission. Then we will have the stimulated emission. So basically the principle is the same. The basic principle, it is absorbing energy and it is emitting stimulated emission. This is the basic principle. Okay, so here we are considering this gas as carbon dioxide gas. Okay, so here when it absorbs light, okay, or when it absorbs the energy, when matter absorbs the energy, it will not sit quietly. It starts vibrating. This will start vibrating. Okay, it starts vibration, or it will be rotating. Okay, so when this energy is absorbed by the matter, in this case the example is carbon dioxide, it starts vibrating or it starts rotating. Okay, so in three ways it starts vibrating. Okay, and also with that it starts rotating. So if it is a molecule, then it starts rotating like this, or it starts rotating. Okay, and then it starts vibrating. So this, if I take as a molecule, then it starts vibrating. Okay, and it starts rotating like this in all the dimensions. Okay, so there are three kinds of vibrations. The first one is it is symmetric mode of vibration. First one is symmetric mode of vibration, or it is also called as symmetric stretching. Okay, so in this case what happens is we have carbon atom at the center, and at the both the ends we have this oxygen. This is the carbon dioxide molecule. This is the carbon atom. If I take single C, then it is called as atom. If I take all these three together, it is called as a molecule. Okay, now we are considering the carbon dioxide molecule, and when we supply energy to this, it goes to the excitation states. Excitation state means it starts vibrating. Okay, so that here this is fixed. Its position, carbon's atom's position is fixed, whereas it will start vibrating. this goes away from the carbon, and this atom is also going away from the carbon and coming back to the center and coming back towards the carbon. It starts vibrating in this manner, in this horizontal direction. Okay, this kind of symmetrically going out and symmetrically coming in is called as symmetric mode of vibration of carbon dioxide, and it is corresponding with some frequency. That frequency is called as symmetric stretching frequency, or it is symmetric vibrational frequency, right? So this is called as the symmetric, and it goes like this, stretching. Okay, and this is also going out like this, symmetrical, and coming in. Okay, whereas this is fixed. This is the first one. And second one is it is bending mode. It is bending mode of vibration, right? In this case, so this is the original position of the carbon, original position of the oxygen, and this is the original position of the oxygen. And here all the three atoms start vibrating in this perpendicular of this bond. So it starts vibrating like this. This will also start vibrating in this manner, and this will start vibrating in this manner. Okay, so that this is going up, these two atoms are going up, whereas this is coming down. That means this is going up like this, and this is going up in this direction, whereas this is coming down. Okay, so this is, there is a bend in the bond, so this is bending. Okay, so this is called as bending mode of vibration, right? So it vibrates in the vertical direction. This will vibrate in the vertical direction. Okay, and all the atoms are not fixed. All the atoms will start vibrating, and frequency with which it is associated is the frequency with which it is corresponding is called as bending frequency. It is bending frequency. And the last one and the third and the last one is asymmetric. It is asymmetric mode of vibration. So in this case, this is exactly opposite of this kind. Okay, whereas carbon dioxide is fixed and oxygen are moving apart. Here, this carbon dioxide, this oxygen, and this is oxygen, which vibrate asymmetrically. That means it not maintain the symmetricity. Okay, randomly it starts vibrating, whereas this is also not fixed. Okay, this will, let us say this is moving in this direction, and this starts moving in this direction. Okay, like this, and this is moving in this direction, whereas this is also going out, whereas this oxygen atom is coming towards the carbon. Okay, and this is going away from the carbon. There is no symmetricity, okay, between these three things. So there is asymmetricity is there, and this kind of vibration is called as the asymmetric mode of vibration, and frequency with which it is vibrating, it is called as the asymmetric vibrational frequency. Okay, so here we have the quantum, and with this all the three things, that is, first one is there, okay, and the second one is there, second one is bending mode, and the third one is there, that is asymmetric mode. With all these three things, we have rotation. Okay, so the molecules start rotating. Okay, so let us say this is the pen is the molecule, then it starts rotating in this manner. Okay, or it starts rotating in this direction. So that is the rotation, and it is also having some kind of a frequency. It is called as the rotational frequency, and it is having the energy correspond to that is called as rotational modes, and it will be having some kind of energy which is lesser than this vibrational energy. And we have whole lot of subject for this, that is vibrational spectroscopy. Okay, how molecules will vibrate in which all different modes. We have the separate subject and research for that. It is called as vibrational spectroscopy. Okay, so which comes under the optics part, and with that we can predict what are the properties of the molecule, what are the properties of the liquid with the vibrational spectroscopy. To indicate this symmetric mode, bending mode, asymmetric mode, we have a quantum number. Okay, it is indicated with this M, N and Q. Okay, so this is very simple. This M represents the symmetric mode of vibration, that is the first one. This N represents the second one, and this represents the third one, that is the asymmetric mode of vibration, right? So if the molecule is having the quantum number 001, okay, if the quantum number is 001 of that particular molecule, then we can say that that molecule is vibrating with 0 unit of symmetric mode, 0 unit of bending mode, and 1 unit of asymmetric mode. What it means is 0 unit means it is not vibrating with the symmetric mode. That means symmetric mode vibrations are 0. Bending mode vibrations are 0. It is only vibrating with the symmetric mode, that means asymmetric mode. That means it is asymmetrically vibrating. Let us say 200 is the quantum number of some other molecule. Then that particular molecule is vibrating with 2 units of symmetric mode, whereas others are 0. What it means is the molecule is only vibrating with symmetric mode. Okay, only it is symmetrically vibrating. Let us say we have 010. What it means is it is vibrating with the 1 unit of bending mode, and this is called as quantum number. And in general it is represented with M, N and Q. This is the quantum number concept. Now the next part is construction. Here we have various components. Let us look at those things one by one. So we have this basic tube. It is the quartz tube. It is the quartz tube. Okay, so this quartz tube is having the length 5 meters. Okay, more or less it is 5 meters long, and it is having the diameter that is 2.5 to 3 centimeters. Okay, so this is the dimension of this, and this depends on the application, and it is also trial and error method, wherein they get the constructive interference. Okay, they'll stop the length of that, and that is the that depends on the trial and error method. So in the different applications, the different lengths are used. Okay, so this already the various companies, they prefer different lengths. Okay, depends on the strength of the laser which they want to produce. Okay, and this is the quartz tube, and which is filled with the 3 kinds of gases. Okay, so that quartz tube is called as the cavity. Okay, or it is also called as the discharge tube. Okay, why it is called as discharge tube? Because we are going to apply the voltage to that, so that the gas is discharged and emission takes place. That's why it is called as discharged tube. And this discharge tube is filled with carbon dioxide, nitrogen and helium gas. So these three gases are mixed in this proportion 1:2:3, or it is in this proportion 1:4:5, and this depends on the application of the laser which we want to produce. Okay. Right. And we have two mirrors here. One is fully gold coated and another is partially, that means semi coated gold mirror. So we already know why we use this fully gold coated, fully silvered gold or silver mirrors, and why we use this semi, because so it has to hit, the emission has to hit here and then come back, and half of that will go out, and again it will come back and feed this discharge tube that we will see. Alright, so these are the gold tubes which are there. And here in this and the pressure inside this tube, okay, pressure is, it is 7 to 17 torrs, okay, more or less 7 torrs to 17 torrs pressure will be there, pressure will be maintained inside this tube. And we have two gold mirrors, one is fully coated gold mirror and there is partially coated gold mirror, and we will see what is the function of that. Already we have seen that, again we will see. And that is the third thing, it is the gold mirrors. So why do we use gold itself? Because this is the noble metal, so it will not there will be 100%, 99.99% of reflectivity will be there. That means all the light which is hitting to this, it will be reflected, and this is a noble metal, that's why we have to use gold or silver coated mirror itself. This is the brewster window here, and here we have the brewster windows. So function of this is the light will be polarized. So this is a kind of a crystal or the crystal salt which is fitted at both the ends. So this makes light to be polarized. That means, what is a polarization? Polarization is light will vibrate in one plane. Okay, so there will be symmetry in one plane, it starts vibrating in one plane. So to make it polarized, so we use the brewster windows. Now, so you may ask why we use this carbon dioxide and nitrogen and helium, mixture of these three things. So we will see the reason for this in the working of the laser. So that is, to make the metastable state, we use these three things, okay, that in the particular ratio. So now what happens is, when the voltage is applied to the discharge tube, so here all we have a gas filled inside this, so here also gas will be there, here also we will be having gas. One is taken as cathode and another will be taken as the cathode and anode. And when we apply the high voltage to this, at that time it starts exciting. The gas molecules inside this will start exciting. How? Because we know that what is the current is a flow of electrons. When we apply voltage, current starts flowing inside this discharge tube, so that electrons will start moving inside this. So what is electron? Electron will start moving inside this, means those will start and hitting to the carbon dioxide molecule, and molecule will be excited. So what happens? The electrons will start and hitting to the carbon dioxide and other gases, so that these all will be excited and emission will take place. Okay, in that manner stimulated emission will take place and this will be discharged. So there will be emission, and the light which is traveling in this vertical direction only gets reflected to and forth many times, and that will be interfered and output as a laser we will get. Okay, the light which is there perpendicular to this, that will come out like this, so which is there, that will simply radiate and come out, and which will not contribute in the constructive interference, that will just escape from this tube. Okay, so the light which is traveling in the horizontal direction, that itself will move to and forth and come out as a laser. So this is the construction part. Okay, still we have the working part which is there. Okay, and the thing is, we have left here, what is this water inlet and water outlet? Since we are applying high voltage to this, we have filled the some particular pressure in this, so there will be okay. So we have another component here, that is water inlet and water outlet. Since this tube heats with a high temperature, because we have some pressure inside this, and we are applying the high voltage to this, so that it will be heated up. To cool that, we use this water jacket. Okay, this water is not going inside this, it is just outer covering. Okay, so that the tube is cooled by water circulation. So this is the another component. Now we will see how it works, what exactly happens to these molecule. Okay, so now we will draw the energy level diagram to this. Okay, what is this energy level diagram? Which represents the energy of the energy states. Okay, so first we will consider the nitrogen, right? So this is the nitrogen, ground state of the nitrogen energy. That means E1. This we will consider is E1. We have now. First, what happens is, when I apply the energy to this, so we are pumping this, we are pumping electrically. Okay, so that it goes to the excited state. That means what? This nitrogen is there. This is the ground state nitrogen. This ground state nitrogen will be hit by electron. Okay, so this nitrogen is hit with the electron, because we are supplying the voltage to that, current is passing inside the tube. Okay, so now what happens is, nitrogen is excited. Always the excited molecule is written with this star. Nitrogen molecule is excited, and the electron will lose its energy. So this is energy of an electron before the collision, so we call it as a collision. This will go and collide with this, and this is excited. It transfers its energy to this nitrogen. It transfers the energy to the nitrogen, and then this is the energy of the electron after the collision. That means it goes to some energy, some higher energy level. So this is the nitrogen. Okay, it goes to the higher energy level. Okay, now this is excited energy level. Okay, so this is going and sitting here. I am considering only one atom, one molecule of nitrogen. So let us call this as E5. So as we know, there will be many energy levels. Okay, E1, E2, E3, E4, E5, like that. So in the earlier cases, we have considered only 2 or 3 energy levels. Now we are considering 5 energy level. What is happening? This is called as first kind of collision. Whereas electron is going and hitting to the molecule, this is getting excited. Okay. Now we will consider the carbon dioxide. We will consider the carbon dioxide energy level. Okay, this is the ground state of that. Okay, and this is the higher state of the carbon dioxide. That higher state is E5 again. So this is same. Okay, so this is the same energy level, that is E5 itself. So that this nitrogen molecule will transfer the energy will transfer the energy to carbon dioxide. What happens is it will again go and collide. So now what we have is this is excited. We know the excited molecule will be vibrating or moving randomly. So this is the nitrogen, excited nitrogen, which will collide with this carbon dioxide. So now it is colliding with the carbon dioxide. What happens when it collides with the carbon dioxide? The carbon dioxide molecule will be excited, and the nitrogen, it comes down to the ground state and it loses its energy. It goes to the ground state. This is excited state. That means this is N2 star here. This is N2 star here. this particular atom is excited. This is N2 star. This is the transferring the energy by the collision to the carbon dioxide. This is going and hitting to this. So this we are representing in the form of a lines, in the form of a graph, and this is in the form of a reaction like a thing. Okay, both are same, right? So now this is nitrogen which goes and hit to this carbon dioxide molecule. This goes and hit to the carbon dioxide molecule, and collision is taking place. Okay, it is transferring its energy to this carbon dioxide so that this is excited. Okay, after collision it is excited and we will get the nitrogen back in the ground state. That means it transfers the energy and it comes back to the ground state. Again it is ready to take the energy, to take the pumping. Again it goes and it transfers the energy. Now what happens is this is E5 state. This is E5 state because it is same state. Okay, energy will transfer by the second kind of a collision. This is called as second kind, where this is the first kind, whereas molecule and electrons are there. Here molecule and molecule collision is called as second kind of collision. Okay, so now this will transfer the energy. So we have, this is E5 state, we have E4 state, and we have E3 state. So this is E3 state. Now this is excited. Okay, and this is transferring this energy to the carbon dioxide. This E5 state is metastable state. This is metastable state. Okay, what is metastable state? Wherein all the atoms or the molecules will accumulate for longer duration of time. Okay, these all are coming and accumulating here, so that there is a population inversion between E5 state and E4 state. There is a population inversion between E5 state and E3 state, so that there is a stimulated emission. Okay, so these atoms, so what all these are accumulated here, what all these molecules are accumulated which are excited, and this is carbon dioxide excited state. That excited state is metastable state. Okay, so this will radiate. So this will radiate, or it will, we can say with the simple arrow mark, this will radiate. Okay, so that this is the stimulated emission. So this stimulated emission will give us, the radiation. So this gives the 10.6 micrometer of wavelength. There is a laser which is coming out, and here it is also the stimulated emission because of the population inversion between E5 state and E3 state. We will get 9.6 micrometer of the output laser. Fine. In this way, this is going and transferring the energy. So there is a population inversion between this and this, so that we will get the radiations, that means laser output. Fine. And next we have E3 state, E4 state. Now we have this E2 state. So here we have E2 state. Okay, from this, without any radiation, these atoms will come down to E2. okay, and then come down to E1, because there will not be any population inversion between this and this or this, okay, and these will come to this E2 without any radiation, okay. So how what helps it to come back? So these all will come back to the ground state using this helium molecule, okay. So we have filled this helium gas inside the chamber, because to take these E4 molecules and E2 molecules down to the ground state. By using this, we can take all the molecules which are there in E3, E4 and E2 state. Those will come back to the ground state. Again, these molecules are ready to receive this energy, that is N2 star energy. Again, it starts radiating, because continuously we are pumping the electrical energy to the gas. We are supplying the voltage to the gas, so that electrons are supplied continuously, and in this way we will get the laser output in two wavelengths, that is 10.6 micrometer and 9.6 micrometer. This is the working of the carbon dioxide laser. Finally, I will assign the quantum numbers to these states. Okay, we have this E1, E2, E3, E4 and E5 states. To this I'll assign the quantum numbers. So this is 0, 0, 1. That means E5 state molecules are vibrating with this 0, 0, 1. Okay, that means what? 0 is symmetric, 0 is bending, and 1 is asymmetric. That means these molecules are vibrating with the asymmetric mode. And now in this case here, okay, it is in this, for this state it is 0, 2, 0. What it means is, these molecules, where in E3 state molecules are vibrating with 0 mode of symmetric, 2 units of bending mode vibration, 0 of asymmetric. That means it is only vibrating with the bending mode. And here it is 0, 1, 0. Okay, it is vibrating with the bending mode. And here this E5 state, this is 1, 0, 0. That means this is vibrating with the symmetric mode. That means if we take the in serial wise, this part is symmetric mode of vibration, this part is bending mode of vibration, and this part is asymmetric mode of vibration. So this is the quantum number. And can you tell me what is the quantum number for this ground state? So this is all the ground state. From this is E1 is a ground state. What may be the quantum number? So ground state means molecule is not vibrating. If it is not vibrating means it is 0, 0, 0. Okay, either this is vibrating nor this is vibrating. So these are in the ground state. When I supply energy, so this will take energy first. It goes to the higher state. Okay, that means it is excited. This transfers the energy. This will radiate in two ways. This is 10.6 wavelength of light. This is 9.6 wavelength of the light, and this will be radiated. It loses energy and comes back with the help of helium to the ground state. That is carbon dioxide, which is there in the ground state, which is ready to take again this nitrogen energy and going to the higher state. So this is what happens in case of carbon dioxide gas, and we will get the strong radiations as output.